Welcome to day 3 of our Explainer series. Today, we're focusing on the mechanical architecture of AI agents. We're going to take a calm, structured look under the hood to see how these systems actually work. Let's start with Section 1, the illusion of magic. When people see an AI agent autonomously perform a complex task, it honestly looks a bit like magic. And there's a really common misconception out there that an agent is just a massive language model stuck on an infinite loop, just generating text until a job is done. Well, actually, scratch that. That is not what's happening at all. Which brings us to a fundamental question. What exactly makes an AI agent different from your standard chatbot? By the end of this explainer, you're going to understand exactly how an agentic system is built to perceive, remember, reason, and act. Moving into Section 2, Anatomy of an Agent. So instead of thinking about code or parameters right off the bat, I want you to imagine you just hired a brand new human assistant to help you run your operations. Now, to do their job effectively, they need 4 basic things. First up, senses. They need to be able to hear your instructions, read incoming emails, or look at a revenue chart. Second, they need a notebook. If they don't remember what you told them yesterday, they're kind of useless, right? They also need long-term memory to recall the fundamental rules of your company. Third, a brain. They need a way to apply logic, plan out their day, and break a massive project down into smaller, achievable steps. And finally, hands. They need to actually physically type the email, issue the refund, or organize the file system. While an AI agent operates on this exact same biological mapping, it extends far beyond just a single static model. To achieve true autonomy, it absolutely relies on separate modular components that process information in a continuous operational loop. The core language model, yeah, that might be the brain. But without senses, a notebook, and hands, it's really just a brain in a jar. It simply cannot solve problems autonomously without these interlocking modules. Okay, let's dive into Section 3, the technical architecture. Let's step away from the human analogy for a second and translate this directly into the formal technical terminology you'll see in software engineering. So the assistant senses become the perception module. This handles input sanitization and multimodal ingestion. Basically, it takes in unstructured text, structured API responses, or images, and normalizes that data safely. Next, the notebook becomes the memory system. This is typically split up into a short-term working memory cache for the current session and a persistent long-term memory, which is often stored in external vector databases for deep recall. The brain, as we mentioned, is the reasoning engine. It utilizes frameworks like chain of thought or React, allowing the system to deliberately plan and sequence its tasks before it does anything. And finally, the hands become the action module. Now, that action module relies heavily on a really important mechanism called tool calling. Tool calling is essentially how the reasoning engine physically invokes external APIs or functions. It's what allows the agent to fetch real-time data, update a customer record, or trigger a whole workflow. It is literally the bridge between thinking about a problem and actually doing something about it. Which brings us to Section 4, Agents in the Enterprise. Let's ground this whole architecture in a real-world enterprise workflow. Imagine you've deployed an AI agent to resolve customer supply chain queries or process financial refunds. When that agent decides a refund is necessary, it uses tool calling to take action. But as practitioners, we have to govern this strictly. A safe, sandboxed API action uses schema validation and least privilege access. It ensures the agent only does exactly what it's authorized to do. Contrast that with an unconstrained action. An unconstrained action carries incredibly high execution risk. Think about an agent hallucinating and accidentally dropping a database table or modifying the wrong customer record. No way we want that. And this is exactly why enterprise systems require robust orchestration layers. You need strict enforcement of secure tool routing and very clear termination rules. The agent must be intelligent, yes, but it absolutely must also be safely constrained. Wrapping things up with Section 5, the core takeaway. We've walked through how an agentic system perceives its environment, remembers context, reasons through logic, and securely takes action. So, your crucial takeaway is this. AI agents are modular, interlocking systems. They are not single monolithic models. They require a distinct perception pipeline, layered memory, a reasoning engine, and a heavily governed action layer to operate effectively. Keep this architectural blueprint in your mind as you build, evaluate, or scale intelligent systems in your own work. And as you design these architectures, I'll leave you with this question to ponder. If an agent's reasoning engine becomes perfectly logical, are your action sandboxes secure enough to handle whatever it decides to do?